Hi everyone! This video looks at a strong base titrated with a strong acid and will focus on the pH calculation after the equivalence point. This is a situation where our titrant volume is more than 0 milliliters, which means we have to set up a millimole table. The E row of our millimole table tells us where we are on the titration curve and guides us as to how to calculate the pH from that information. In this sample millimole table, we are only looking at the E row. Here, we see that the hydroxide goes to 0, which means it has completely reacted. The H plus titrant is greater than 0, which means there is excess, or more than what was necessary to fully react with the base. This situation puts the reaction progress in region 4 of the titration curve, which is after the equivalence point. To calculate pH after the equivalence point, we first have to calculate the H plus molarity. We get this by taking millimoles of H plus from the E row and dividing by the total volume. We get the total volume by adding together the milliliters of base and acid given in the problem. Once we have the H plus, we can calculate pH directly by taking the negative log of that value. So the first thing we'll do in this problem is calculate our millimoles. Starting with hydroxide, we have 15 milliliters of solution times the molarity of the sodium hydroxide, which is 0.2500 moles of OH minus per liter of solution. Liters of solution will cancel. And checking our sig figs, we have 4 sig figs for the volume, 4 sig figs for the molarity, and so our final answer of millimoles will be also rounded to 4 sig figs. Doing the math, 15.00 times 0.2500 gives us 3.750 millimoles of OH minus. For our H plus, we have 21.66 milliliters of solution times the molarity of our HCl, which is 0.2000 moles of H plus per liter of solution. Liters of solution will cancel. For our sig figs, we have 4 sig figs in our volume, 4 sig figs in our molarity, so our millimoles will also be rounded to 4 sig figs. Doing the math, we have 21.66 times 0.2000 rounded to 4 sig figs gives us 4.332 millimoles of H plus. Our next step is to set up our millimole table. Our reaction is OH minus plus H plus going to water. We set up our rows ICE and add our units of millimoles. Our values that we just calculated are 3.750 millimoles for OH minus and 4.332 millimoles for H plus. Subtracting the smaller value, minus 3.750 for each reactant, will give us 0 for hydroxide and 0.582 millimoles for H plus. So we can see, because we have H plus in solution and the hydroxide has gone to 0, this is after the equivalence point. To do our calculation, we need the molarity of the H+, so we get that from 0.582 millimoles of H+, divided by the total volume, which is 15.00 plus 21.66 milliliters. For our sig figs, we have 3 sig figs in the numerator, 4 sig figs in the denominator, so our molarity will be rounded to 3 sig figs. Doing the math, we have 0.582 divided by 36.66 milliliters, rounded to 3 sig figs, gives us 0.0159 molar H+. From here, we can calculate the pH directly by taking the negative log of that molarity, so the negative log of 0.0159. Because we have 3 sig figs in our value, we will round our pH to 3 decimal places. So taking the negative log of 0.0159, we end up with 1.799 for our pH.